Hi, I'm going to take another crack at this photosynthesis redox reaction. It's been a little while on some of these harder ones, and I had a look at how to do it. The charge states that I was using weren't as ideal. I think the ones that were suggested look a lot better for being states to work on. So here we go. We're going to have a look at doing this, working this out. So what do we have? First off, we want to balance this. So we have carbon. So we have 1 on this side and 6 on this side. So we're going to need 6 here. Now we can also look at our hydrogen. How many do we have? Here's where we've got the big number. So we have 12 here and we only have 2. But if we have 6 here, then we're going to have 12. So then we're good there. And then on the oxygen, what do we have? We have 12 right here, 6 times 2 plus 6 to get 18. And then on this side, we have 6 plus, well, we got to get to 18, something times 2 to get the right answer. You're going to have 6 times 2 will give you your 12, so then 6 plus 12 will give you your 18. So we need a 6 there as well. So now we'll have a look at the charging oxidation states. If I can erase this, there we go. I haven't erased this really in this mode before. There we go. Okay, so now we'll get into the charging and the actual charge numbers that when I looked it up, this makes a whole lot more sense. Generally, in a compound, oxygen is a -2 charge. Okay, so that's usually the case. When it's a gas and it's bonded to itself, equal pulling of electrons, so it's a 0 charge. So we already know we're going to have an oxygen -2 state to an oxygen 0 state. And we know we're going to have to add electrons. So we know we've got that part going on. Now let's look at the carbon. In order for this carbon to balance here to get a 0, +4 state for carbon would balance off 2 times -2. And so +4 plus -4 gives you your 0. So we know we have a carbon 4 state. Sometimes we draw it that way. It's commonly drawn. And then on this side, this whole positive one, I was thinking about the negative one, which does happen with hydrogens, but let's look at it this way. It's much more common, so it's a better setup. So we have oxygen that is -12. We have hydrogen, 12 times positive, so it's going to be a +12. And in this case, carbon's going to be a state of 0. And carbon does have a bunch of different charge routes that it can go. Often with something like sugar, it's a carbon chain. These would all be little spots. You have carbons. They're really horrible, but it's a zigzag chain that I do really, really fast. And then you have your oxygens and hydrogens off. And so you can kind of see that likely the middle will have a 0 charge, and then you can have some positive and negatives on ends of things. So I can see why it's more likely that carbon wouldn't have a charge. So in this case, for your carbon, you're going from a +4 charge to 0. To offset that, you're going to need 4 electrons. Okay, and then you have to start thinking about how to balance it off. If you've got 2 electrons going on here and 4 here, you're going to have to multiply this whole thing by 2, which probably makes sense because you have oxygen 2 here. Okay, so then this can become your O2, and I don't know if your charging is really happening. It's probably collectively happening, some from carbon dioxide and some from oxygen. Doesn't really matter because it's a -2 charge in both cases, and you're going to need a 2 oxygen here leading to the O2 on this side. Now with carbon, you're going to have to think of how you've got 4 carbon there. It gets a little wishy-washy, but as long as we're balancing our electrons and we can add this up, we can at least see where things are adding up. Okay? And O2, 0 plus 4 electrons plus your carbon state. And your electrons are canceling out. Oops, so I did not cancel electron there. Oh, I'm not sure how to undo one step. We cancel our electron here, and we cancel our electron here. We get left, I'll restate it just in case that looks really confusing right now. There we go. Okay, and those zeros, I'm just putting them up there as a reminder. Like I say, when we put it up into the main equation, it's by default, if you don't see a 0, it means the charge is 0. Okay, so that gives you a sense of, you've got two equations happening. So you have a gain of electrons. So your carbon part is doing reduction. And then you're losing electrons in LEO, so that's oxidation. So this is showing you how this is a redox reaction for photosynthesis. It's not as clear. It's not as easy to then go from your final adding up your two half reactions and then putting it back into the equation, but it's probably this little portion. So you'll have like an oxygen off here, you have a double bonded oxygen here, or something like that, that is doing the reacting part. So it's a little more complicated to pull it back into that main full reaction. I would really have to work at that for quite some time to get there, but at least you can see how the beauty of how it all works together. And just like math, whatever you put in, you gotta equal out on the other side. It's very neat how math and chemistry and these sciences are similar.